All right, so today's lesson is on the law of cosines. And last time we learned the law of sines, and the law of sines helped us to solve oblique triangles. An oblique triangle is a non-right triangle. But the law of sines will not work for certain pieces of information. If all you know is the three sides, or the two sides and the included angle, law of sines is not going to work for those. You don't have the right pieces of information. So then we have this, which is law of cosines. So it consists of three different equations. So let me just give you a moment to copy that down. Now, in this course, I will not ask you to memorize the law of cosines. You will have notes available for you. Perhaps in some other course you might take, an instructor might expect you to memorize them. But you do want to be familiar with them, see the pattern that we have. And what you want to do is make sure you understand the notation, that the lowercase letters A, B, and C represent side lengths in your triangle, and the capital letters A, B, and C represent the angles. And then you can see, so you have a side squared is equal to the other two sides squared minus 2 multiplied by those two sides times the cosine of the angle of that side that you're working with, right? So you see it, side A squared here with cosine A, side B squared here with cosine B, side C squared here with cosine C. So you should observe the pattern of the formulas there, but again, you don't have to memorize them. So let's do an example together. All right, so as we look at this example, right, let me scoot this guy up a little bit, zoom in. Notice that the information that you have been given is side, side, side. So remember for that the law of sines, right? So back to law of sines, it said sine A over A equaled sine B over B. You can't be missing both angles and use law of sines, right? If you don't have any angle measurements whatsoever, law of sines is not going to work out. So we're going to use law of cosines, and we're asked to find the measure of angle A. So our first task is to decide which one of these we need. So if we need to find angle A, we're going to use this top equation. So I'm just going to write that down here. A squared is equal to B squared plus C squared minus 2BC cosine of A. Once we've looked at our drawing and figured out which formula we need, guys, now we're just plugging and chugging. We're just substituting and doing a little bit of algebra. So we have to decide which one of these is A. So here's angle A, right? So side A is across from angle A. So side A is 6 feet. Side B is across from angle B. So side B is 24. And then side C is across from angle C, so that's 20. And so then side B was 24. side C was 20, and then cosine A. That is the work right there. Knowing what your sides and your angles, what's what. Now you've plugged it all in. So we've got 36 is equal to, and then you're going to just put this stuff in your calculator. And when you do 24 squared added with 20 squared, you're going to get 976. So you want to go ahead and do these two guys together. All right? And then you're going to multiply 2 times 24 times 20. That's going to give you 960. And then you've got cosine of A. Now, the one mistake that I have seen students make at this point is you're not going to do subtraction. Do not subtract 960 from 976, right? Remember your order of operations? Your PEMDAS, please excuse my dear Aunt Sally. 960 times cosine A. So multiplication comes before subtraction. Do not subtract these two numbers. We're trying to get this value by itself. So we're going to subtract 976 from both sides. We're going to get negative 940 equals negative 960 cosine A. Then we're going to divide both sides by negative 960 because this is multiplication here. And then, guys, there's no reason to carry out this division unless you just feel like it. But I am going to say a negative divided by a negative is a positive. And then, if I want to get A by itself and I have cosine A, I need to take the inverse cosine of both sides. Inverse cosine and cosine undo each other. So I have A. Once I have my variable by itself, that's when it's time to pick up my calculator. Make sure your calculator is in degree mode, right? And then A is going to be 11.7 degrees if they said to round to the nearest tenth, or 12 degrees if they said to round to the nearest degree. So this problem didn't tell us. With degrees, sometimes you round to the nearest whole degree. That kind of makes sense. Occasionally to the nearest tenth. You usually don't go any more precise than the tenth of a degree because a degree is already a fairly small unit. Alright, so that's an example of using law of cosines with a side problem. Alright, second problem. We've got a triangle here, so draw a triangle ABC. And we know that the measure of angle C is 65 degrees. And we know side AC is 8 and side BC is 5. And we need to solve the triangle. So notice that the information that we have here is side, angle, side. And so notice that law of sines won't work, because if you do sine of angle C, but this is side C over here, and I don't know side C. And then this is side B, but I don't know angle B. And this is side A, but I don't know angle A. So I don't have the right pieces of information to do law of sines. So I am required to use law of cosines. Law of sines isn't going to work. And I need to use the law of cosines that's got angle C in it, because that's the angle that I know. So when I go over to my law of cosines, I'm going to use the bottom equation right here, because I've got angle C in my problem. Right? So I'm going to put down C squared equals A squared plus B squared minus 2AB times the cosine of C. I don't know what C is, so there's a variable. Again, side A is across from angle A, so I've got 5 squared. Side B is across from angle B, I've got 8 squared, minus 2 times 5 times 8 times the cosine of 65 degrees. Now, hint, before you start doing a bunch of calculating here, we want to get C by itself, right? So we're going to take the square root. Squares and square roots undo each other. And then take the square root of this whole entire side. And then you can just type all of this into your calculator at once. When you do so, make sure that when your calculator opens parentheses for you, you close them in the appropriate spot. So we've got 5 squared plus 8 squared. Calculator's just extending the square root sign, which is good. Minus 2 times 5 times 8 times the cosine of 65. We're in degrees, check. Close your parentheses for your ending of cosine. I usually like to just arrow over, make sure that little square root doesn't dangle off the end, and hit enter, and we get 7.4. Generally with your side lengths, you round to the nearest tenths. So now C is equal to 7.4. So now that I have that bit of information, I still need to do angle B and angle A, but I've got choices now, right? I know all 3 sides, so I could use law of cosines. Law of cosines is kind of longer to write than law of sines. So if I want to do angle A, I would probably go with law of sines at this point. So I would go sine A over A equals sine C over C, right? Because now I know this angle and this side that are across from each other. So sine A over 5 is equal to sine 65 over 7.4. Cross product, 5 times sine of 65 equals 7.4 times sine of A. I'm trying to find A, so I'll divide both sides by 7.4. 7.4 divided by 7.4 is 1. Now I need to undo sine, so I take the inverse sine on the left, inverse sine on the right. Remember, you're taking the inverse sine of that whole entire side. Inverse sine and sine undo each other. A is by itself. When the variable is isolated, time to use the calculator. Inverse sine, 5 times the sine of 65. Now right here, your calculator opens your parentheses. You've got to close it around the 65. Divided by 7.4, then close that set of parentheses, and then we get 37.76. We'll round that. Now we're on angles. Let's round to the nearest whole angle. It'd be 38 degrees. All right, and now we need angle B. We could find angle B with law of cosines, law of sines, but don't forget about that triangle inequality, or that triangle sum theorem. The sum of the angles in a triangle is 180. So the measure of angle B is just equal to 180 minus the 65 from angle C minus the 38 from angle A. .77 degrees. Okay, at this point, quick check for reasonableness. Let me come put my answers on my triangle. This guy's 38 degrees, 77 degrees. Remember, shortest side is across from the smallest angle. Obviously, picture's not really drawn to scale, right? That 5 looks longer than that. But shortest side is 5 across from smallest angle 38. Largest angle 77 across from longest side 8. In between angle measurement of 65, side length 7.4 is in between these two. My answers are all reasonable. Doesn't guarantee that they're correct, but it guarantees that they're not way out of line.